Welcome everybody to the webinar today. We're really excited to have you here. We have been looking forward to this presentation by Pytes for a while. My name is Heather Smith. I'm the marketing director at NAS, and I've got two other members of my team here who will be monitoring chat and answering questions. That's Benjamin Allen, who is our lead application engineer, and Joe Foltz, who is our wholesale manager. So they will be here answering questions. I'll be dropping some links in the chat as well, so keep an eye on the chat. If you have questions, again, you can answer them there. We'll take Q&A at the end, but mostly I want to thank Pytes for being here today and doing this presentation. It's always helpful for our customers to be able to ask questions directly to the manufacturers and get more information about their products, learn about what's new. So I want to thank August and Logan with Pytes for being here doing this presentation. And I'm going to go ahead and kick this over to Logan, and he's going to get us started, and we'll try and stay on time.
Perfect. Thanks so much, Heather, Benjamin, and Joe for hosting. My name's Logan. I'm product manager with Pytes USA. I'm joined here by our sales manager, August. And I'm going to pass it over to August, actually, to kick us off. She's going to do a quick little intro about Pytes, just to get everybody a little bit more familiar with us as a company. We'll jump in from there to the main theme of the presentation today. That's going to be our introduction to our new V10 battery. I've got some content on our high voltage commercial solutions as well we'll touch on. And then we'll come back around to wrap it all up with some installer benefits and talk a little bit more about our certified installer program. So August, go ahead.
Sure. Thank you. Thank you so much. Thank you so much, everyone, for joining us today. Super excited to be with NAS team and with you guys in this meeting, in this webinar. It's so great to see everyone here again. So my name is August, sales manager at Pytes here. And here I'm with my co-worker, Logan. We call him a walking encyclopedia in Pytes, very knowledgeable product manager. So feel free to ask any question today in the chat box, or later on we can discuss in the Q&A session. So let's get started. To the next page. Previous one. The one like earlier, agenda. I like to talk about the agenda today. That's right. Yeah, so I'd like to introduce Pytes a little bit for everyone who are on the call today who are new to Pytes. And then after that, Logan will intensively introduce our next generation V10 and high voltage solutions to everyone. In the last section, we will offer some resources for installer, because Pytes value user experiences, and also we value installers' experiences. So we will introduce some like resources that we can provide as a manufacturer. We can provide and support our installers. Okay, you can do next page. All right, we're gonna start our company introduction. So Pytes has been in this battery manufacturing industry for over 20 years. And we started in the year of 2004, and we headquartered in Shanghai. Now we have over 1,000 members, employees with Pytes team in 6 continents, like over 60 plus countries. So for our North American team, we have 4 warehouses located in Los Angeles, Dallas, Puerto Rico, and Panama. And if you are looking at the pictures at the lower level, we have our Shanghai as one of our manufacturing facility. And we have 2 facilities in the northern part of China, Shandong. And we also have Vietnam manufacturing facilities to support you guys do the manufacturing. Okay, we can do next page. All right, so Pytes is a big company, and we have 3 divisions. So the first division is we call it LEV, the Light Electrical Vehicle division, and we manufacture battery packs for e-bike and e-scooter. If you guys ever heard about Ride Power Bikes, we're the main supplier. And we also have the division for consumer electronics. For example, electric toothbrush or electrical shaver. Pipes manufacture cylindrical cells. So probably your personal items nearby you are using pipe cells. For example, the 18650, something like that. Yeah, and also we have the most important energy storage division, and we have a wide range of choices, options for residential solution or commercial solution. For example, we have the solution like in different style of batteries, rack style batteries. Probably some of you guys here already very familiar with Python V5, the first one on the left hand. We match it with different variety of cabinet solutions as well. For example, this is a V-Box OC, can contain 4 pieces of V5 batteries, very flexible. And we also have our next generation solution, which is V10. The second one is actually V10. Yeah, and it's IP66 rated and with a lot of new features add on. Logan will introduce later on. And also we have stackable batteries, very slim, save space, and save the footprint as well. And we also have this is one of our high voltage solution. It's high voltage 4800. All right. So from here, I really want to introduce a few things, but I do want to first highlight Python as a manufacturer. There's no hesitation that we choose the best cells, the tier 1 cell and chips. We choose the best technology, cell technology, because safety is our top priority. Safety is so important and user experience is so important. We always choose the best for choosing the raw materials. And also, there's another highlight I want to share with you guys is we have the full control of the supply chain. We're the real manufacturer. We're the direct manufacturer. And that is really reducing the dependency on the external suppliers. In another way, is protecting our ecosystem, like distributors, installers, and end users. Like your healthy ecosystem. Yep. And also, it's just amazing to think about starting from raw material preparation, and after so many stages, we hand it over, we deliver to our end users. That is amazing, like to fulfill everything. And another thing is that I want to highlight is production plus distribution are very important. Every step of the way is very important. So we really appreciate the partnership, the collaboration with NAS team. We're always running to support our customers. We're not walking, running, because we always respond so fast and so rapidly to support our customers. Thank you so much again for NAS team, and thank you so much again for our installers and end users as well. All right, so here another feature here I want to highlight is our self-designed BMS. This is so important because BMS, after several years of accumulating data, debugging, we are actually getting a better version year by year. So iteration matters. So that means like after several years of accumulation, you get a better version of products and actually optimizing the performance of the battery and also enhancing the safety of the energy storage system. So self-designed BMS, that's Python do. And for another thing I want to highlight here is that right now, based on the right now we have the previous data was our failure rate is only 0.3%, which means 3 out of 1,000. But based on the recent data, we received this number even lower than this. It's around 0.18%, something like that. So truly that Python is choose the best material, best technology. We reduce the failure rates. We improve the user experiences because our user matters and user experience matters. All right, so we can jump to the next page. Yeah, so before I hand it over to my coworker Logan, we'd like to invite you guys to watch a video together. So here we go. That's okay. And here you go, Logan. Thank you so much.
All right. Thank you very much, August, for the intro. Yeah, sorry about the sound there. You didn't miss anything though. It's just kind of cheesy background music, but that is on our YouTube if you want to take a look. And essentially what I'll try to do for the presentation today is kind of touch on each one of those new features or additions that we saw in the short intro video there. So before we jump into that, just a quick overview of some of the technical specs of the new V10 battery. It's kind of like the big brother to the V5 as I explain it. I know NOS has been offering our 5 kilowatt hour V5 server rack style battery for a couple years now. And this, carries with it the same quality and reliability that everyone's come to know from Pyte. So as I said, big brother of the V5, it's a 10 kilowatt hour battery, so essentially twice the capacity. The battery itself is outdoor rated, IP66 rated. We're still using, tier 1, top of the line automotive grade lithium iron phosphate cells. As we saw, there's a whole bunch of additional safety features and also functionality features that I think will make this a really, really good product going forward. This is something that, I think is targeting kind of the small to medium scale residential market, especially if somebody's looking for an outdoor rated solution in the maybe 10 to 40 kilowatt hour neighborhood is sort of the sweet spot for the V10. We can of course scale up higher than that, but yeah, I think that'll be the main customer base to start with anyways. But one other thing to point out is the warranty on the V10 battery has been increased. So it does come with our standard 10-year warranty, manufacturer warranty. You can extend that to 12 years for an added cost. So potentially up to 12 years of total warranty coverage. So just a couple other technical specs here. Recommended charge current and discharge current for V10 is going to be 120 amps, so about 6 kilowatts in and out. Max continuous discharge is a little higher than that at 150, closer to about 8 kilowatts. And then touched on this a little bit already, maximum scalability. You can go pretty easily up to about 80 kilowatt hours without our hub accessory. And then employing the hub accessory, which is really just a simple communications manager device, we can go up to close to half a megawatt hour at about 500 kilowatt hours. So one of the key, I think, elements of the V5 and, sort of touching on this concept that August introduced about improvement over time. One of the things I think we at Pytes do very, very well is improving on past versions of our product and, making sure each new battery we release is a little bit better more efficient, longer lasting than its predecessor. So V10 is no exception when we look at that compared to V5, and even more so when we look at that compared to our original server rack battery, the eBox. But V10 is going to have an extended cycle life at 8,000 cycles down to 90% DoD. But the key, behind the increase or the improvement anyways, is a higher capacity prismatic lithium iron phosphate cell. So V5 and most of our other batteries in our product line, both in high and low voltage right now, employ a 100 amp hour 3.2 volt prismatic cell, whereas V10, we're jumping up to a 230 amp hour cell. So this is going to give us more efficiency compared to the 100 amp hour. It's a little more cost effective to manufacture the larger cells as well. So that savings, trickles down to the retail price or end user price for the product. And what's interesting to me is because we have, a higher. The only other thing I wanted to add here is due to these higher capacity cells, we've actually been able to significantly increase the total energy throughput for V10. So with our V5, our eBox batteries, that total energy throughput, which is essentially just a rating of how much total energy you can put into or take out of the battery throughout its entire life. Our previous models, it's about 19, somewhere between 19 and 20 megawatt hours for our 5 kilowatt hour server rack batteries. So V10 is going to have a throughput that's more than 3 times that amount at 60 megawatt hours, even though we're just increasing the capacity by double. What's interesting as well is when we look at V10 compared to our existing solutions, because it's 10 kilowatt hours by itself, because it's outdoor rated by itself, we don't need an additional battery, we don't need an outdoor cabinet. It does actually save quite a bit when we look at, for example, our V5 battery plus our outdoor rated cabinet. And same goes for our outdoor rated stackable battery, the Pi LV1. So when we compare V10 against those other two options, same capacity outdoor rated installation, you're actually looking at somewhere between 20 and 25% lowered cost, which is obviously great for everybody there. So yeah, outdoor installs, I think it's really going to shine. And to reiterate that point even more, I think the first thing I like to talk about for V10 is the casing. So it does have an IP66 rating, which for me is quite interesting. If you look at the IP, right, ingress protection chart, you get two numbers. One of those is a rating for the ingress of solids like dust and particles. And the other one is for the ingress of water. So there's a lot of products out there that have an IP, 5 something or 6 something. But for me, the second number is significant, right? So if you look at the chart, we're at IP66, which means, it can take like direct water spray to the product. But notice what I think is interesting is the next level above or better than the 6 is a 7, which is basically full-on submersion underwater, right? So where you can say like one level or one step away almost from, being able to dunk the battery underwater and still be able to use it, which for a battery, that's significant, right? You could have this on a dock, even potentially on a boat, where, there's salt mist, there's lots of water. And then as well, the case, both inside and outside, has a very high degree of corrosion resistance. So really, something that would work very well for a coastal application or, a high humidity environment. Think Puerto Rico, parts of the southeastern United States, for example. And then we've also made an improvement to the heating pad inside the battery. So our V5 battery does have an internal heating pad that allows you to do charging in cold temperatures. V10, that concept is still the same. Granted, it's a larger battery, so the heating pad is a little bit more powerful at 250 watts. But what's interesting is we've actually made the heating pad in a way to where it is now in contact with all of the 16 cells within the battery. V5, you had, I think, 3, maybe 4 separate pads, if you will, spaced strategically throughout the battery case. And sometimes that can lead to some temperature differentials, but with the new and improved heating pad, we're expecting I think a lot more consistency related to temperature within the pack anyways. So highlighting some of the safety features, the big one for me is an aerosol fire suppression system. This is something that's going to engage automatically if the temperature within the battery exceeds a certain value. I think that's about 400 degrees Celsius. We've also added a decompression valve or pressure relief valve. So again, if the BMS inside detects that the pressure within the battery exceeds a safe value, this little button here is going to pop out. It's going to allow that gas buildup to vent and prevent something more dangerous from occurring, if you will. And then lastly, we have added ESS emergency shutdown functionality to the battery. So that's done through a dry contact interface RJ45 port. You can essentially connect a push button to one of the COM ports on the battery, and then with the press of that button, your battery shuts down. It's actually going to open the circuit between the battery and your equipment. So you have no DC voltage, leaving the battery or on your inverter charge controller terminals. This also works in a parallel installation. So if you have multiple V10 batteries in parallel, because those batteries are communicating with each other, pressing the ESS stop on the master battery is going to trigger the shutdown for all the followers as well. One thing I want to be clear about these two features especially, right, is the fire suppression system and the pressure valve. So these aren't things we're expecting to be used ever. And if they were to engage, it would be, a worst case scenario, catastrophic battery failure. And essentially what these are designed to do, it's designed to prevent the propagation or the spread of thermal runaway if, again, the battery were to have a catastrophic failure. So to be clear, there are no known issues or records of thermal runaway occurring within a Pyths battery that we've tested or had in the field. And, these are really just for, residential fire safety. And again, not expecting these to be used in a normal circumstance. So just keep that in mind, right? Worst case scenario to prevent a thermal runaway propagation. So being that Pyths has been in the battery game for over 2 decades now, and being that we have designed and made our own BMS battery management system right from the get-go, with every product or iteration of batteries, that BMS technology gets better and better, more efficient, safer, more reliable. And we employ a MOSFET BMS in our solutions as opposed to a contactor BMS. So those are kind of the two main methods in the market at the moment. And essentially, right, a contactor, it's similar to a circuit breaker maybe, or a switch where we're physically disconnecting or reconnecting, opening and closing a circuit. MOSFET's a little bit different. You can think of a MOSFET as kind of an electric gate. Yeah, the MOSFET method is something that we have found to be better than the contactor-based BMS, being that there's no moving parts. It's all solid state components. It's a lot more efficient as well. Contactor BMS, you do need some amount of power to keep the coil either open or closed, where as MOSFETs operate due to their nature, there's very, very minimal, almost none standby consumption. Again, no moving parts. It means it's got a higher lifespan and I think a much higher reliability when it comes to vibrations and movement and things like that. I will say for sure contactors can handle much higher current values and voltage values than a MOSFET, but the way we've designed our solution, we have a series of MOSFETs, multiple of those components doing the job for us. So you do have some redundancy as well. I did want to add as well here that we have a pre-charge circuit built into the V5 or V10. So what that does is it lets the battery slowly energize the capacitors of an inverter. so that we don't cause any damage from inrush current. So that's a feature actually V5 and eBox battery does not have. And I've seen a few cases in the field where one of the internal components in the battery, like the power board, can sometimes be damaged if you connect a big inverter without a disconnector or breaker, right? So really good feature, I think, to just increase the overall reliability of the product. Kind of touched on most of this as well. I think the only here to recap is the circuit breaker on the battery. It's 125 amps rated, and it actually disconnects both the negative and the positive pole. So if one of those poles were to fail or not open or close right, you can still potentially open the circuit with just one of the two poles, positive or negative. This is just a view of the breaker cover. It does have a lockable breaker cover. We can see the little breaker there, power switches, dip switches, startup button, and I'll touch on that in a bit here. But this is a quick view of the packing list for V10. So you do get a set of 1-aught cables that can either go up to your inverter or your bus. This cover plate, which is going to cover up all the terminals and comms port on the battery to maintain that IP66 rating. And when you're doing an outdoor install and you use this cover plate, there's another conduit attachment piece that's included that will let you route conduit in and out directly to and from the battery. It also includes a wall mount bracket, kind of like the French cleat hanging style bracket. If any of you have installed a Solarc or a lot of the other common all-in-one inverters, a lot of them have that. So makes the install quite easy. The battery is, I think, roughly 200 pounds, 220 pounds. So this is kind of a nice thing because you don't have to, sit there and try to hold the battery up to secure it in the wall. You're just doing this first. You also get some battery-to-battery comms cables, grounding cable, and we include a blank RJ45 cable, or plug rather, if you have to make up a custom communication cable. So couple shots in more detail of that wall mount bracket. As you can see here, the battery has a flange on the back, or kind of like hooks that will just sit right on top of that little piece of the bracket there. But really self-explanatory, right? You take the bracket, mark your holes on your wall or mounting surface, looking for the studs or structural members, and then secure the bracket. From there, you pick the battery up and set it on top to hang it on the wall. So to assist with that process, we're working on a lifting dolly that's going to help elevate that battery to its position so it can be mounted. And then we've also got another accessory that are lifting handles. So these are big metal bars, basically, that slide into the back of the battery. You can kind of see there in that photo that will let two people, one on each side, lift that battery into place in order to hang it on the bracket. So another accessory we've developed is a floor mount bracket. The V10 can be wall or floor mounted. So for floor mount installations, maybe we don't have wall space, maybe the structure of the wall isn't capable of holding up that weight. You can set it right on the floor as well with this accessory. And then the last optional accessory is our Wi-Fi dongle, and that can be used to remotely monitor the battery. This is actually the same dongle accessory that we use for our V5. So kind of nice we're not introducing another SKU there, but you can see a shot of the dongle right here on the right, and we have it sitting outside of our cover plate so that the metal here does not impede the internet signal going to the dongle at the bottom. So a couple of other shots of that cover plate and the conduit attachment piece. You can kind of see here on the left, I suppose, what it's covering, and then again conduit knockouts on top there for a direct connection. So similar to I think a lot of our products so far, especially V5, we've got some basic LED indicators on the battery that are going to tell you if there's a fault or alarm, or if the battery's in protection, if the BMS senses temperature's too high, voltage is too low, etc. A running light to indicate whether it's in standby or charging, and then you've got this capacity indicator which will give you a rough idea on your battery state of charge. The user interface wiring area on the left, I think I introduced a lot with the lockable breaker cover and what's in there. Wi-Fi dongle port. We've got our power terminals, positive and negative, our comms port on top. Two of these ports will be for battery to battery comms. This one here is that dry contact interface for our ESS shutdown. And then over on the right, the COM port that's going to have our inverter communication cable for closed loop. So a couple of examples just to show, I think, the relative simplicity of V10, especially when you look at a single inverter system, right? So a 1-to-1 battery to inverter ratio, we'll say, very, very simple. Whether it's indoors or outdoors, there's really not a whole lot of extra stuff you're going to need to facilitate that. Same thing if you look at a 2-to-1 battery to inverter ratio, and especially if we're using an inverter with 2 battery inputs, such as the Solarc 15K. Very, very easy and straightforward as well. You're essentially making your final parallel connection between the 2 batteries right there in the inverter wiring compartment. So we've got a couple accessories, additional accessories, I should say, installation accessories that are coming very soon to help make all of our installers' lives easier when it comes to setting up the V10. One of those is our C-Box SE. That's a conduit box that you can see here. This is something that has holes that are pre-drilled, especially for a Solarc 15K. So, rather than running conduit, for example, you could just sit one of these boxes on top of the battery, situate your inverter directly on top of that, and again, makes the install, I think, even easier. And with multiple batteries as well, you may have to run conduit between the 2 boxes, but to facilitate that, we have another version of the conduit box. This is just the C box, and that's actually going to have an integrated bus bar inside, 500 amp rated. I think there's 5, maybe 5 or 6 studs there for ring terminal connectors. So yeah, integrated bus bar in the box. You can also just get the box by itself if you're not combining multiple batteries or multiple inverters. So couple quick configuration examples with the V10 with common inverter models, Solarc, and I've got Lux Power on here, which is essentially, I'll say, Fortress Envy, if you will, in a different brand. But essentially what I'm doing here is just basic, really, really simple math to determine the minimum battery quantity we need to satisfy the max continuous AC output of each of these inverter models, but also how many batteries do we need to safely and continuously accept the max charging current from all these different inverter models. So in these examples, like I said, it's very simple math, basically just Ohm's law, volts times amps is watts. And you can see here in some of the examples, right, we're getting 1.17 batteries is what's needed to fully satisfy a Solarc 12K. Well, can't have 0.17 of a battery, so we're going to round that up to 2 batteries to get that 9,000 kilowatts, or I'm sorry, 9,000 watts continuously. The 2 that I want to focus on in the case of a Solarc 15K or something like a Lux Power 12K is, notice when we do the math here, the numbers are different, right? If you're looking here at a 15K Solarc, let's focus on that example. That inverter has a 12 kilowatt AC output off grid without PV or assistance from grid or gen, right? That 12K is all coming out of the batteries. So in order to satisfy that 12,000 watts continuous based off our 150 amp max discharge on the battery, we'd need 1.5 batteries. So we're going to round that up to 2 batteries, right? When we look at the charge current of that same inverter at 275 amps, and the continuous charge rating of the battery is just slightly lower. Usually we don't charge batteries as hard as we discharge them. It's a little easier on the cells, helps the battery last longer. But notice how when we look at that 275 amps for the battery bank to accept continuously 275 amps, you need technically 3 batteries, right? For me, either one of these numbers is perfectly acceptable, and I would have no problem at all somebody doing a 2 battery install on a Solarc 15K. I think more often than not, you know, your end users, your customers, homeowners especially, they're going to care a lot more about this stat, max continuous AC output, than they are about this max charge current. So in other words, what I mean there is, for example, when the grid goes out, most people are going to want maximum capability. They want to be able to use everything that the inverter can supply and is rated for safely. Whereas the charging, maybe not so much of a priority, again, for most people, right? I don't think anybody's going to be too concerned if it takes, you know, 3 hours to charge their batteries as opposed to an hour and a half or an hour and 45 minutes, for example. So interesting, you know, looking at both specifications there. But again, I think hitting that continuous AC output for most is going to be the priority, right? Some of the safety certifications, we've pretty much got everything done. I know we just finished our UL 9540A for thermal runaway. That's being evaluated now, and as long as no issues there, we should have full UL 9540 certs with, or excuse me, by the end of September. And that will be the newest, or at least I think it's the 2023 edition of 9540. Which means you can pair it with basically any inverter that has a UL 1741 cert, and that system will be fully qualified. So one of the themes that both myself and August have touched on so far is this progression of our products over time. So when we look at something like our eBox 48100R on the left, this is basically inside the battery. We're opening one of the cell packs. And here we can see, you know, half, essentially 8 of our 3.2 volt prismatic lithium cells. And you'll notice here we've got this traditional copper wire harness method, basically little tiny small gauge wires from each cell back to a common board to monitor temperature, voltage from each of the cells there. So when we moved from eBox battery, which again, that's our sort of founding product, if you will, in the ESS world, something that's been on the market for nearly 8 years now, if not a little longer. When we came out with V5, which again is kind of the predecessor to V10, we got away from this wire harness setup here, and we went with a much more efficient, much more streamlined, flexible printed circuit board to enable our cell contact system. So does the same thing. It's the same concept, right? We've got the battery open. We're looking at the inside of one of the cell packs, and we can see it just by appearance alone. I mean, it looks a lot better. It's lighter weight. It reduces the volume that we need inside the battery. And honestly, it's a lot more reliable. There's not as many issues or errors when it comes to you know, measuring cell level data. Sometimes in our eBox battery, I've seen cases where one of these gets loose, or the little board that collects all the info fails, and you know, you've got one cell or a couple cells showing some crazy abnormal value. This other setup here with the flexible printed circuit board is much more reliable and you know, efficient overall. So think I touched on that concept pretty well, but just another example of progression in our low voltage product line, right? eBox 48100R was a really solid product for us, without a doubt. V5, I think, was even better. And you can see from V5 going to V10, right? All of these added features and you know, increased capacity and all that we've reviewed. So again, one of the central themes of Pyths is every product we make is a little bit better than the last. That's a great segue into our next low voltage addition, and that's our V16 battery. So this is extremely similar to the V10. I won't spend a whole lot of time on this, but just as an introduction that this is also coming in the pipeline, all the safety features, all the warranty, you know, corrosion resistance, fire suppression, et cetera, that's in V10. It's also in the V16. Biggest difference is V16 is this spec here, this 314 amp hour cell. So this is going to give the battery a 16 kilowatt hour capacity as opposed to 10, and even more so a higher energy throughput overall, getting up to about 92 megawatt hours over the course of the battery's life. So I know we're sending or planning to send a sample to NAS for evaluation, but again, just another addition to our low voltage line, and something that I think will be a very successful product overall. All right. So we've talked a little bit about low voltage. I know I've focused on V10 primarily, introduced some about EBOX, V16, V5 even. I do want to introduce a little bit about our commercial line of products, just so everybody knows. This is also something we do and are continuously improving as well, just the same as we are in low voltage. So before we switch gears, it's important, I think, to go back to the basics a little bit when we talk about low voltage and high voltage, right? Maybe it's getting a little bit confusing, especially for those that don't do high voltage systems or kind of new to it. I know I myself had to study a bit to make some of the concepts make sense. But anyways, what we're all familiar with and used to, low voltage systems, 48-volt systems, you connect all your lithium batteries in parallel, positive to positive, negative to negative. You're maintaining that 48 volts on the DC bus, but you're increasing your amp hour capacity. High voltage systems are the complete opposite. We're still using essentially the same batteries, but we're connecting them in series, positive to negative, instead of in parallel. So think back to our lead acid days when we did, two strings of 8, 6-volt batteries to get a 48-volt system, etc. All that math and the concepts still apply here. We're just talking about essentially different chemistry. But to be clear, right, our low voltage batteries V5 and our high voltage batteries HV48100, they're the same capacity, they're the same voltage, 51.2 volts with 100 amp hours. The only thing that's changing is the connection method. Low voltage, you're in parallel, high voltage, you're in series. But at the end of the day, if your battery quantities are equal, your energy is still the same, right? 6 batteries here, 6 batteries there. Even though the voltages are quite different and our total amp hour capacities are quite different, your energy is always energy. So it's still the same, 30, 31 kilowatt hour battery bank either way. Pros and cons to these two methods, right? I think low voltage by far is still the most widely accepted, most widely used. Easy to source those components. It's easy for DIY installers, easy to retrofit existing systems. On the other hand, high voltage, you've got your PV strings and your AC output and your batteries all much closer together, which is going to help to reduce conversion losses. We're working with much smaller cable, usually number 6, number 4 gauge max, as opposed to sometimes big, heavy 4-aught cable on the low voltage end. For sure, a lot more cost effective for larger systems, especially 3-phase C&I projects. It's the way to go. And then ultimately fewer components and accessories. Given the way that we've designed our high voltage batteries, our indoor cabinets, our outdoor cabinets, they're very much plug and play, I would say. And nearly everything you need for a complete install is going to be included in the packaging. So moving through this a little quickly, just for the sake of time, main thing I want to point out here is when it comes to our high voltage setup, the main difference is we're actually introducing another component, okay? And we call it the BCU, or battery control unit. That works in tandem with our BMUs, or battery module units, in that the BCU is sort of your primary BMS, and essentially telling all the BMUs how to operate. This is the thing that's communicating with the inverter. This is where the user, the installer, is interacting. And yeah, sort of the component sitting in the driver's seat. This is not a battery, so this has no cells. This does not store or discharge energy. That's what the modules do. But you can see how simple the high voltage modules become now that we've built all that more advanced functionality into the BCU. Part of the reason for that is with high voltage systems, you typically need more than just one battery for a fully functioning system. So with our setup, you need at least 5 battery modules, 25 kilowatt hours, to satisfy the minimum requirements of the BCU. And then you can see here just a simple diagram where, again, confirming we're connecting in series, not in parallel. So HV48100 is our high voltage battery for three-phase or C&I applications. And it comes in three, I'll say, flavors at the moment. The only thing that's different between these images here is the cabinets. The modules and the BCUs are identical. So we have an 8 battery cabinet. This is a 40 kilowatt hour solution, a 12 battery cabinet that's 60 kilowatt hours, and then a 15 battery cabinet, which is, I think, 76, 78 kilowatt hours, somewhere in that neighborhood. So pretty self-explanatory on these two, right? You're connecting 8 in series, you're connecting 12 in series. This one's a little bit different. You can do a couple configurations. You could do 2 parallel strings of 7 in series. You could also do 1 string of 15 in series. And again, why you would do either one of those kind of just depends on the inverter being used and what its input voltage requirements are. To add all of these options that you see on the screen are indoor cabinets. And the first generation of our high voltage batteries do not have any built-in heating, cooling, or fire suppression. So these are fairly basic, but again, still the same, manufacturing and design quality that we at Pytes are known for. Packing list for the HV48100, just to take a really, really quick glance, like I said, comes with pretty much everything you need to connect the modules together within the cabinet, but then also what you need to connect that cabinet up to your inverter. And it's really straightforward, especially when we look at some of the high voltage inverters in the market that our batteries are compatible with right now, such as Solis, such as Solarc. Most of these have 2 battery inputs as well. So whenever you do a 1-to-1 or a 2-to-1 battery to inverter ratio, you don't really need any accessories, and your bill of materials basically becomes just 4 items, right? Your inverter, your battery cabinet, your BCU, and then your corresponding number of BMUs. And this is just something to highlight, the difference in configurations depending on inverter model. So like I said, some inverter models have higher input voltages, like our incoming Solis 3-phase models. Those have an 800 volt max input. Solarc 60K is 700, Solarc 30K is only 500. So because these have different maximum battery input voltages, right, with some inverters like a 30K, we can only connect 8 modules in series as a maximum. So if you needed more, energy than what 8 modules can provide, or 40 kilowatt hours, that's totally possible. You just have to create another stack or another group, and then, either land it on the other input of the inverter, or if you exceed that 2-to-1 ratio, right, then we're looking at additional accessories like a high voltage combiner in our hub. You can also do lower, I'd say maybe with the inverters that have higher input voltage ranges, you've got a little more flexibility into how many modules you can use. And of course, right, the number of modules you have connected in series directly affects the power output that those batteries can supply for your inverter. So kind of a quick glance, some of the differences there. And then just highlighting a couple of our commercial projects, some of the early installations with HV48100 that have been successful. This is a residential system in Hawaii that I've helped to commission. You can see they've got 4 cabinets. They've got 2 inverters, so really, really simple setup there on the battery side. This is another system with very, very similar components in Mexico. And then this one I think is really interesting. This is in Suriname, sort of a lesser known country, I'll say, in South America, where something like 95% of the country is dense Amazon rainforest. And this is an eco lodge in the middle of the jungle that's only accessible by boat or plane. There are no roads, there's no cars, there's nothing out there except wilderness. So this is something I like to highlight. It is, the most off-grid system I've probably ever been involved with. And it's up and running, fully with, I think, a 120 kilowatt solar array, some Solarc 30K inverters, and then about a half a megawatt hour of our high voltage batteries. So that's one that I always like to show off, and just to showcase what's possible, with this technology. Again, coming back to this theme of continuous improvement, every next product that comes from Pyte's factory is better than the last. High voltage is no exception. That feedback that we get from our distributors like NOS, from our installers, from our end users is super, super valuable in helping us grow and advance and stay relevant. So high voltage SE cabinet is an outdoor rated cabinet now. This has a 15 battery capacity, integrated fire suppression, a 5-layer, detection and suppression system. It's got an air conditioner built in. Heating now is included in the modules. You can kind of see in that shot there, the modules have ventilation fans built in as well. And again, just being better at every step, as much as we can. We've also simplified quite a bit the communications here. So whereas instead we needed to use our hub accessory and high voltage combiner, for example, the new components included in the outdoor cabinet are going to make the design and the installation quite a bit simpler. So same progression shot, if you will, but on the high voltage side, right, going from that first gen to the second gen, lots of improvements, mostly related to fire suppression and the outdoor cabinet. We've also got a higher capacity HV48-300 model in the works that's employing a 280 amp hour cell, I believe. So still all the same safety features, heating and cooling, etc., but now in an even higher capacity where your cabinet can be maximum about 215 kilowatt hours inside, instead of just the 70 or 80 as before. So I know I went through that pretty quickly. We can absolutely work with NOS to organize another training that's more of a deep dive into high voltage. I think there's a lot that goes into that, especially in terms of configuration and design, that is different than low voltage, which again is probably more familiar to everybody. At least it was for myself. So yeah, happy to set that up and again share any resources, but just a simple little intro on our commercial line. And I'm going to pass the mic to August for a moment to highlight on some of our installer benefits at Pytes.
Hey, that is right. Thank you so much, Logan, for all the information. We learned quite a lot from you. So now I'd like to introduce about the benefits and also the resources that our installers can use for yourself and for your end users. Right now we call this program as PPP. It's Pytes Power Partners. So in this program, you will get all kinds of benefits. So I want to highlight a few. The first one is cell leads. So whenever Pytes receive the request or needs from home users, we will send those leads directly to our distributor, for example, Nuts Solar Electric, and then our distributor will give it to you based on the territory. So the number one is cell leads. The second one is the training. So the training, we have different type of training. For example, we have the online webinar, to introduce the new products, releasing the new products, or we can even set up the training for even more technical related troubleshooting or BMS upgrading and so on. And also we like to collect your feedback on what kind of training, what kind of topics you guys are interested in, and we can design the lesson, we can design the class for you guys. We always love to hear about your feedback. And also we have the on-site training. That means we host the training in our distributor's warehouse or the facility. For example, at the end of September, we are planning to host one on-site training, hands-on training with Nuts team. We will prepare all the gifts, materials, and products so you guys can do the hands-on. We usually plan it like a lunch and learn, the full day event, so you guys can really do into the hands-on practice of troubleshooting and also learning the products and also the networking.